Hello and welcome to Samples for School Lung Dissection. So in this dissection we're going to be looking at a lung pluck, and in your sample you can have it with or without the liver and the heart attached as well. We're just going to do a simple run through of the lung system today. So the first thing we can notice is the larynx attached to the top of the sample. So this is the voice box and it houses the vocal cords for the animal to make their noises. But what we can see here is the entrance to the airways that we're interested in. We're going to be looking at the trachea, the main windpipe of the animal. And we've got this ingenious little flap-like area here, which we call the epiglottis. And this is for when the animal is eating, it can close the entrance to the trachea to stop any food debris going down the trachea into the lungs. And that is because running completely adjacent down next to the trachea, this long pipe, is the esophagus, the pipe that the food bolus travels down into the stomach. So this soft, flexible tube, that's the esophagus. This more rigid, slightly striped tube, that's our trachea. And that's the one we're looking at because it takes the air into the lungs. If we follow the trachea down into the animal, we can see that when we get to this soft, spongy lung tissue, it branches. And it branches like a tree into two bronchi, one into each lobe of the lung. Those bronchi then continue branching out, just like a tree, into the whole rest of the lobe of the lung, right down into the very lower areas. And it means that the air that comes down the trachea can get right down into all of this large surface area. Now, we need the trachea to stay open at all times. So in order to do that, we have these rings of cartilage. In your sample, you're going to cut down the trachea to expose these cartilaginous rings. There. Now, if we cut them open, you can see each line of cartilage. But they're not complete rings. In fact, you can feel that there's a soft spot on the underside. And that's because they are C-shaped rings. And that means that the esophagus, if you're swallowing a large amount of food, it has some flexibility to allow that esophagus to press up against the trachea without constricting the airway. If we turn the lungs the other way up, we can see where this then corresponds to the rest of the intestines, the liver and the heart. We've got some remainder of the main heart vessels, and we can see where the liver was once attached, down here. So we've made some small incisions in here so you can see the spongy nature of the lung tissue. And this is what we call the alveoli. They're the air sacs that fill up with the gas as we breathe in. And this is an incredibly specialized gas exchange surface. We're going to remove some of this lung lobe and see if it does still contain air. If it does, it will float in the water. So when we look in this sample, you can see the smallest branches of the tubes, the bronchioles, and they are still rough and rigid to touch. That's because they still have that cartilage in to keep them rigid and open. So if we put a muscle tissue into water, it sinks, and that's because it doesn't contain oxygen. If we compare that with some of our lung tissue, it does float. And that's because those alveoli sacs still contain oxygen. Now, if we look back at the lobe that we took it from, you can see the ends of the bronchioles that connect to the alveoli, that transport the oxygen into those alveolar sacs. Now, they are incredibly specialized for gas exchange. Those sacs are very thin, so there's a short diffusion pathway for the gases. And they are lined up against a huge, efficient capillary network, so there is a good blood supply to carry that oxygen away from the lungs and to the heart. The third thing that makes it efficient gas exchange is that the ventilation of the lungs itself. That network of bronchioles means that oxygen gets to every aspect of that lung, so it's a large surface area. Thank you for watching our lung dissection. If you'd like to know more, please see our website, Samples for Schools, for risk assessments and lesson plans. Thank you.